2, 1, we're back. Introduction to creating perfect squares. When you're dealing with quadratic equations, your kind of ultimate goal at some point might be that you want to take a quadratic in standard form and then maybe put it into vertex form. Now, before you get to that, let's try to see and introduce how perfect squares or completing perfect squares kind of works. I'm going to take this first assumption here. So here's my quadratic expression, but I am going to assume that a is equal to 1. So I'll take the simplified form first. And our ultimate goal will be if this b right here is given to us, so if we know what this number is, we're going to try to figure out if from that b we can create a c so that we have a perfect square as a quadratic. Now, just a recall, so for perfect squares, so here's 3 perfect squares for quadratics. So for instance, here's the first one, here's the second one, and then the third one. Now, why are they perfect squares? Because when you factor them out, you will get a perfect square. So meaning, so you can actually create a square where the sides are basically identical. So for that first one, this would have been this side, and of course if you try to take the area, you're going to have exactly this right here, and that is my perfect square. And that happens in the second example, and then it also happens in the third example. And in this video, what we want to try is we want to try to see that if we know what this b right here is, or this or that. Now, the sign does not matter to us as much. Now, of course, it will matter because notice the sign on your second term is basically telling us what happens there in the bracket. So I'm just highlighting that for you. Now, if we have that second kind of term, so if we have this b given to us right here, then our goal is going to be, okay, can we find this c so that we can create a perfect square out of our quadratic? That's going to be our goal for this video. And again, I'm going to assume that I have a is equal to 1 in the first case. And I will do a video where a is not equal to 1. And when that video comes around, I'll add a link up above there so that you can go back and forth between the two videos. Let's start it. Now, for these quadratics, so what we have is we basically have all our quadratic. So if I have an expression here, so they look kind of like this, bx plus c, that's my standard form. Now in this video, I'm going to assume that my a is equal to 1, so I'll erase that a from there. And now, if you want an actual perfect square, then we know that what we're going to try to do, and I'm going to first assume that, we have a positive right here. We're going to try to find our c so that we basically have some kind of a perfect square as a result. Now, I wrote a beta there, so that little funny b that you see. And that beta simply is, okay, something that we want to be able to find. Now, if I would expand this entire thing, what I would get is x squared plus 2 beta x plus kind of beta squared. That would have been my actual form of this perfect square that I would have. Now, what I'm going to try to do is I'm going to now try to take the 2. So I'm going to take this one right here. Let me duplicate it, put it down right there. And I'm going to take this right here, and I'm going to match them. So I'm going to try to see what is actually needed in order for those two things to be identical. I'm going to try to find what the c right here should be. All right, based on that. So let's take a couple of steps, and then I'm going to show you through examples. At the end, it's actually pretty simple in this particular case, but I want to break this down to you so that you can see where it all is coming from and how to kind of derive it for yourself. Well, for this example, what I have is, notice that I have my b, and I'm going to be assumed that this b is given. All right, what we're trying to find is c. If b is given, then what I do know is that b is equal to 2 beta. And that is just coming from right there because that is the term with the x only. The x squared just has a 1, right? So we have a 1 here and a 1 here, so nothing really to match. But this, okay, I have that. Now, if I try to solve for beta, my beta right here is going to be equal to just b divided by 2, which shouldn't surprise you because it is perfect squares. Now, that beta, which is equal to b over 2, what that would mean is that if I was trying to find my beta, and I'm going to highlight it within this equation, so this right here, okay, that would have been my beta. It would have been x plus, and then basically b over 2, and then I would get the rest. Now, if I want to be able to find my c, then I have to also match. I'm going to be matching my c right here. So my c is equal to beta squared. But wait a minute, I know what beta is. Beta is just b over 2. And if you substitute that in, what you will find is that my c is equal to, if I substitute for beta, so I'm going to have that c is simply b over 2, which is the number in front of your x, divided by 2, and then all you do is square it. And that is it. That's how you can actually find your c to create your perfect square for quadratics. Let's take a look, okay, and see how we can make this happen with several of the examples. But before I do that, I want to just go back in here. So the ones, these quadratics that I showed you, these original ones right there, let me kind of clean this up a little bit so that it's nice and easy to be able to view here. I'm going to take these right here. So these ones, okay, I just want to highlight it for you. All right, let's expand this up. And now notice that indeed we can try to test what we just did. So if we wanted, now of course all of the information here is given, right? I know my b and I know my c. But let's imagine I didn't know my c. And that way what I would do is I would take my b, so this is my b, which is 2. And what do we do, okay, in order to find our c? Well, we know that that beta is simply b divided by 2. Well, 2 divided by 2 is 1. And then that 1 we have to square in order to get the c. That's exactly what we're saying right here. Right? So we're going to take b divided by 2 and then we're going to square it. And that's what we got here. So indeed, this indeed should be 1 if we want a perfect square. The sign, this sign right here that we see, is just the sign that goes inside of the bracket. So it doesn't actually do any impact on our numbers. Now for the second one, so for this one, this is 4, right? It is negative, so notice that you have a negative there. But if you take this 4 now, you divide it by 2, you're going to get 2. And then if you square that 2, you're going to get 4, which is your c, and that would create your perfect square. Same thing happens here. Notice you have 16. If you take 16 and you divide it by 2, then what you're going to get is 8. And then 8 squared is going to give you 64, which is your c. And now if you want to be able to factor them out, you can do so if you like in this particular case. Because you have your perfect square, you know what your beta is, and from that beta right here, it is very easy to be able to even find the factored form. Let's do that on several examples where the numbers aren't actually given right here. So first thing that I look at is I always kind of take a look and see, all right, well, what's the sign? So these are the signs that I have in front of my b. I'm going to try to be finding this c in all of these. Notice I just put a question mark there. And now afterwards, I'm going to try to factor it out. Now, what I have is, okay, so for that first example, so example number 1, I know that here is my b, right? So my beta is going to be equal to, so it's just simply b divided by 2, and that is going to be 6. Now, if I want to find my c, so that question mark right there, well, c is just simply equal to b over 2, okay, which is your beta squared. Well, I know what that was. This was 6, right? So b over 2 is 6, so that goes right there. Now 6 squared is just simply 36. So that question mark, and that completes my square, so this is x squared, and this was plus or minus 12x, and then it's going to be plus 36. And now in factored form, so this is x, notice again, the sign just tells you what that will be. And then here, it's just beta, which is going to be the 6. And that's your perfect square. So it's not very difficult in order to do that. Let's try to do it for example number 2. In example number 2, so I have 10. Now that 10 I can divide by 2, which is going to be 5. Now 5 squared is 25, which means that here, so this question mark now becomes 25. And in factored form, okay, so because my beta is just 10 divided by 2, and the sign there is positive, so this is going to be just 5, and then that's your square. And you've now completed the entire square right here, and you could factor it in that way. For question 3, notice that your b is actually an odd number, and it is also for question number 4. So if you're going to have odd numbers there, or even, even if you had fractions or even if you have decimals, it doesn't really matter. It still follows the same procedure, but the numbers just won't be as nice, right? Because you're going to get into either fractions or you're going to get into decimals that you would carry. Typically in school, they would give these numbers to you so things kind of nicely work out, which isn't really reality because most of the time these numbers are not very nice. But they're trying to teach you kind of what the process is instead of kind of what reality numbers. Numbers in reality are not always the greatest. But in this case, the process is the same. So what I would do is I would have 15. 15 divided by 2, all right, so in this case it would be 7.5 if I want to keep it as a decimal. And then it would be 7.5 squared. Now, I'll actually keep it as just 7.5 squared here. And if you like, you yourself, can actually square this and find out what that number is. Or you can keep it as a fraction, which would be 15 over 2. And then you can just square that entire thing if you wanted. But that's how you find your c. And then for the last one, okay, so for this one right here, well, we have 21. And 21 divided by 2, which is going to be 10.5. So that means we're going to take 10.5 and we're going to square it, and then we found our c. And that's all that you actually would do. That is it. Now, if you want to factor them, of course, you know your betas, so you can find your beta in both of these cases. Okay, so here's the beta, which is 7.5, in that case 10.5. Don't forget the sign just tells you, okay, so what would happen. So for this one, for instance, it would have been x minus. For this one, it would have been x plus, and then you can complete your square as needed by putting the beta. So that would have been 7.5 for that one, and then 10.5 for this one. That is it. All right, so that's the introduction to these particular perfect squares where a is equal to 1. See you in a future video. Bye, everybody.